The next question is we have to find the value of W. So notice that this angle here is the angle at the center, and from the same starting points A and C, there is an angle being formed on the circumference. So we can apply the property angle at the center is twice the angle at the circumference, which makes this angle 52 degrees. Also, if this is 21, this is 104, we can find this angle over here, and then by using vertically opposite angles, we can find this angle over here, which would be the same, and then we can find W. So now let's find the purple angle at the left. That's going to be 180 minus 104 minus 21. This gives us 55. So now these purple angles are 55 degrees, so we can find W by subtracting 55 and 52 from 180. We're getting 73, which is the answer. In the next question, we have to first find angle ADC, so that's this angle over here. Now notice that vertex A, D, C and B, there are four corners of a quadrilateral that are also touching the circumference of the circle. So then this kind of quadrilateral is called a cyclic quadrilateral, and in the cyclic quadrilateral, opposite angles sum up to 180 degree, or in other words, angles in the opposite segments are supplementary. So if this angle is x, so x plus 42 plus 28 equals 180, and when we'll rearrange and make x the subject, we'll get 110. Next we need angle ADB. So where's that? ADB. So we need this angle. Alright, so how do we find this angle? It's actually, this angle has A and B as its starting point, so it's being subtended from point A and point B, and there's also another angle in this circle that is being originated from A and B. It's this angle at C. So these two angles would be equal. So if this is y, this is also y, and that's 59. So because of vertically opposite angle, this would be 59 as well. So now we can find y by subtracting 59 and 42 from 180, which should give 42 and 59, which should give us 180 minus 42 minus 59, which gives us 79. Okay, so that's the next question. Here we have to find the value of angle W, X and Y. Let's start with angle W. So this is angle W, and notice that this is angle at the center being subtended from point A and C, and from the same 2 points there is another angle being subtended on the circumference, which is W. So W would be half of 108, which using the property angle at the center is twice the angle at the circumference. So this is going to be 54 degrees. And then if I have W, so using angles in the opposite segments or using cyclic quadrilateral, I can find angle W, because angles in the opposite segments are supplementary. So sum of this W and X equals 180. So this is a property of circle, W plus X equals 180. W is 54, so X would be 180 minus 54, which is 126. Next we need angle Y. So for angle Y, again this is still a cyclic quadrilateral, so sum of this angle and this angle over here would be 180, and this angle is 120 because angle is on a straight line equals 120. So 180 minus 60, sorry, is 180. So 180 minus 60 is 120, and to find Y, we'll do Y plus 120 equals 180, which gives Y equals 60. Again, the property being used here is that angles in the opposite segments are supplementary, also known as opposite angles in a cyclic quadrilateral sum up to 180. Okay, now in this question we have to find y, z and t. So to find y, this and this, they're the radius, and radius are equal in length, so this is an isosceles triangle, so this is also 50. So y will be 180 minus 100, 180 minus 50 minus 50, which gives us 80. So y equals 80. Then we need angle z. So for angle z, we know that radius and tangent, they are perpendicular. So this is the radius, this is the tangent, they form an angle of 90 degrees. So this angle would be 90 degrees. So z would simply be 90 minus 50, which is 40. And next we need angle t. So the angle t can be found by using sum of interior angles of a triangle equals 180. So now we know y is 80 plus t plus 90 equals 180. So t is equals to 10. Okay, in this question we have to find first angle AOB. So where is angle AOB, and we have to find these angles in terms of x. So AOB, so this angle is needed. Notice that this is the radius and this is also radius, which makes this triangle an isosceles triangle. So this would be 2x as well. So now we can find 180 by we'll find the middle green angle by subtracting 4x from 180. So this would be 180 minus 4x, which is the first answer. Answer for this is 180 minus 4x. Okay, next we have to find angle ACB. So angle A to C to B, it's this angle, and notice that it's being formed from point A and B, and there's another angle being formed from point A and B on the center. So we'll use the property angle at the center is twice the angle of the circumference. So we'll have to divide the center angle with 2, take 2 common in the numerator and cancel it with the denominator. So we get 90 minus 2x, which is the answer for part B. In part C, we have to find angle DAB, DA and B. So we need this whole angle. How do we get to that? Okay, so for this, I know that this angle here, right here, would be equals to x. Why is that? Because this angle is being formed from the starting points A and D on the circumference of the circle, and another angle is being formed from starting points A and D on the circumference of the circle. That's this angle. So if this is x, then this also has to be x. So this orange angle here is x. So I need the red angle. I have this orange angle x. Now all I'm left with is, if I have this angle, then I can find the red angle. So again we have this angle as well. So notice that these two angles are again making angles in the same segment, this angle and this angle. And we found this angle in just the last part, which was 90 minus 2x. So this angle here is 90 minus 2x. Now we can find the red angle. So the red angle is angle DAB. So angle DAB will be 180 minus the orange angle, which is x, minus the purple angle, which is 90 minus 2x, which gives us 180 minus 90 is 90, and minus x plus 2x is plus x. Okay, in the next angle we have to find angle ACB, this angle, and also give a reason for each step. Give a reason for each step of your working. So we need this angle. Okay, so how do I get to this angle? First I can find this angle easily, because this is the radius and this is the radius. so this would be 28 as well, and then this would be 180 minus 28 minus 28, right? So this would be 180 minus 28 minus 28, which gives us 180 minus 28 minus 28 gives us 124. So this angle is going to be 124. The reason you'll write here is one isosceles triangle, triangles, let's assume this is the correct spelling, and then sum of interior angles in a triangle equals 180. Do mention that as well. And then now we need the purple angle. So this the property angle at the center is twice the angle at the circumference is being applied, so that means the green angle is double the purple angle. So we'll simply half the green angle divided by 2, which gives us 62, which is the answer. And you'll state the reason that angle at the center is twice the angle at the circumference. So you have to state all three reasons, this one, this one, this one, and the third one. Angle at the center is twice the angle at the circumference. Okay, in the next question we have to find angle D, this angle here. So notice angle D is originating from points K and J, and there is another angle forming on the circumference originating from J and K. That's this angle over here, which makes this D as well. This would be D as well. Okay. Similarly, it's given in the question that JL is the diameter. So if this is the diameter, then angle subtended from the diameter is 90 degrees. So that makes this angle here 90 degree. And we can use vertically opposite angles and conclude that this is also 100.